Well, hello YouTube. I've got something that I guess I would like to show you. I've been programming a new OpenGL game using STL2 in purely C for the last 7 or 8 hours and thought I'd make a video about it. Here is the very basis of the game. It's not even really a game, so much as a voxel render. All that's really happening on the inside of this program is I create a chunk, and the chunk is just a line of memory that holds a bunch of blocks, and each block takes up 8 bits of space, not bytes, just bits. And then from that chunk, I pass that to another function that creates this mesh, and the mesh is just a string of points in space for all these triangles. Each block has 12 different triangles, as you could expect, and that is sent directly to the graphics card, and then everything is freed from memory. After that, I'm free to just fly around in space. The program doesn't actually know that any of these blocks exist after I send them to the graphics card. It's just me flying around, and it renders as it will. The interesting thing that I've come across is that this is only a 20 by 20 by 20 chunk. I can make that quite a bit larger. Whoops, I have this open somewhere else. Here it is. Let's fat finger everything, why not? So here we go. That didn't work, because I forgot to save this. There we go. This is going to take a minute, as you could expect, because it's now randomly filling 1,000 by 1,000 by 1,000 chunk of virtual space with blocks. And the way it does that, well, it just picks a number and puts that many blocks randomly throughout the large chunk. In this case, it is filling this chunk 0.1% of the way full. That is about 100,000 of these small blocks, and the big chunk contains 1 billion potential blocks. Turns out, then, that the original malloc to hold the entire array for the chunk is a gigabyte in size. That is half the surprising part, to be honest. The fact that I can call a malloc, and you have to call a malloc because the stat cannot deal with an array of size 1 billion. But the fact that I can repeatedly call mallocs of a size 1 gigabyte and fill them with data, and that quickly, I think is remarkable. And then secondly, I'm generating this many of these little tiny cubes. And it works flawlessly. Through the very center, I don't know if you can see it, there's a line. That's just that I've made the program so that when it creates a chunk, it automatically creates a line of blocks from one corner to the other. So that's not a glitch. Did have some glitches that I had to work out with stray lines, but they're gone now. Yeah, even with 100,000 of these blocks, I am doing culling, but I'm not doing any face checking. It renders completely fine. I found that if I back up enough, I can sometimes get my frame rate to drop below 60, and of course when that does happen, it turns out that because I have vertical sync on, once a single draw call takes up the time of more than 1/60th of a second, it just goes ahead and takes up 2 spaces, so that my frame rate drops immediately to 30, but honestly it's right around 60. Quite consistently. So yeah. From here on, I'm just going to keep pushing the chunk size up and see what can happen. when I type in run, it automatically compiles my program again from source. Oh. It's taken quite a bit longer, but it has not crashed yet. Here we go. So now instead of 1000 by 1000 by 1000, it's 1100 by 1100 by 1100. And I think it's just absolutely ridiculous that I can do this. All this matrix math has been done by hand. I haven't used GLM because GLM is only available for C++. And I thought I'd just go ahead and learn how to work with matrices. So there we go. There we go. So this segmentation fault right here, that's what happens when this malloc fails to work. Just kind of seg faults, because I'm not doing any checks to see whether the malloc failed or did not fail. I just assume it does. And as bad as that is, I'm too lazy to put in the check. But for 1000 by 1000 by 1000, I found that it works pretty much every single time. So yeah. I'm just gonna fly through this for a while and have fun with it. I like how, when you back away far enough, the points are completely random. And again, I don't know if this will show up very well through the video, but you can see where the back edges of this cube are, just because they get just a little bit denser in the in points. It's also kind of interesting when I turn on wireframe mode. Excuse me. The background of the blocks, or the blocks in the background, get quite a bit brighter because the blocks that would only take up 1 or 2 pixels wide are now being drawn 3 or 4 pixels wide, as the lines that they draw are about 2 pixels wide. It's an interesting thing. So yeah, there you guys go. See ya.